Alright, 2.1, use inductive reasoning. Alright, we're just going to go over a couple of vocab terms. A conjecture is an unproven statement that is based on observations. Okay? A conjecture is very, very similar to like a hypothesis. Inductive reasoning is the process of finding a pattern for specific cases and then writing a conjecture for it. So, we'll do an example down here. When you are given a problem in which you look for a pattern and then you make an educated guess based on that pattern, you're using inductive reasoning. Okay? I'll show you what we mean when we get to example 1. Alright? A counterexample is a fact or a specific case that proves a conjecture wrong. So, if I made a statement and you gave me some specific example that proved my statement wrong, you gave me a counterexample. Alright, so for example, describe how to sketch the fourth figure in the pattern, then sketch the fourth figure. Okay, so figure 1, it looks like it's divided in half. Figure 2, it's divided into 4. Figure 3, it's divided further. So each rectangle is divided into twice as many equal regions as the figure number. So in figure 1, it's divided into 2. Figure 2, it's divided into 4. Figure 3, it's divided into 6. Okay? So, in order to sketch the fourth figure, we have to divide the rectangle into eighths. Okay? So something like this. It doesn't have to be beautiful. Now also notice that in each of the figures, the lower left-hand square is shaded. So in this case, it would be this one. So I'm going to shade the section just below the horizontal segment at the left. Excuse me. Okay, checkpoint. I'll let you guys do this one. Let's go on to page 2. Okay, describe the pattern in the numbers, -1, -4, -16, -64, etc. Write the next 3 numbers in the pattern. Okay, notice that each number in the pattern is 4 times the previous number. -1 times 4 is -4, -4 times 4 is -16, -16 times 4 is -64. We just keep multiplying by 4. So, in order to get the next number, I'm going to multiply by 4 again. Let's get out the calculator. 64 times 4, 256, make sure it's negative. To get the next number, we got to multiply by 4 again. 1024. And the last number, -4,096, negative. Alright. Example 3. Given 5 non-collinear points. Remember, non-collinear means that these points do not make a straight line. Make a conjecture about the number of ways to connect different pairs of points. Okay, so we're going to make a table and look for a pattern. Notice the pattern in how the number of connections increases. You can use the pattern to make a conjecture. Alright, so in this case, when there's only 1 point, we have no connections. 2 points, we have 1 connection. 3 points, we have 3 connections. 4 points, we have 1, 2, 3, 4, 5, 6. 6 connections. Notice how when we get from this one to this one, we add 1. From here to here, we add 2. From here to here, we add 3. Probably, we're going to add 4 to this one and get 10. So, you can connect 5 non-collinear points 6 plus 4, or 10 different ways. Alright, I'm going to let you guys do this, this checkpoint. Let's go on to page 3. Numbers such as 1, 3, and 5 are called consecutive odd numbers. Consecutive means they come one right after the other. So, for example, 1, 2, 3, 4, 5, 6, 7, etc. These are consecutive. 2, 4, 6, 8. These would be consecutive even numbers. So 1, 3, 5 are consecutive odd numbers. If I were to just pick random numbers like 4, 8, -3, 10, these are not consecutive. So consecutive means they come one right after the other. Find a pattern using groups of small numbers. So let's see here. 1 plus 3 plus 5, that's 9, which is the same as 3 times 3. 5 plus 7 plus 9, that's 21, which is the same as 7 times 3. 3 plus 5 plus 7, that's 15, which is 5 times 3. 7 times 9 times 11, 27, which is 9 times 3. So it looks like the sum of any 3 consecutive odd numbers is 3 times the second number. Here, the second number is 3. 3 times 3 is 9. Here, the second number is 7. 7 times 3 is 21. 5 times 3 is 15. 9 times 3 is 27. So, let's test our conjecture using other numbers. Let's try -1 plus 1 plus 3. That gives us 3. The middle number is 1. 1 times 3 is in fact 3. Here, this gives us, let's see here. That's 315. Middle number is 105. 105 times 3 is 315. We're good. So both of those work. Alright, now let you guys do that checkpoint. Example 5. A student makes the following conjecture about the difference of two numbers. Find a counterexample to disprove the student's conjecture. The difference of any two numbers is always smaller than the larger number. Okay, so basically, if you take two numbers, like 8 minus 5, whatever you get is going to be smaller than the bigger number. So if I have 7 minus 1, I'm going to get a number that is smaller than whatever the bigger number is. We need to find a counterexample. We need to prove this wrong. Okay? Basically, we need to find a difference that is greater than the larger number. For example, let's use a negative number. 8 minus -4. Remember, a minus negative becomes positive. 8 plus 4 is 12. Because 12 is not less than 8, a counterexample exists, and the conjecture is false. So, this conjecture, it may work for some cases, but it doesn't work for every case. We've already found at least one case for which this does not work. Alright, page 4. Making conjectures from data displays. Okay, the scatter plot shows the average salary of players in the NFL since 1999. Make a conjecture based on the graph. So, it looks like their salaries are going up since 1999. So the scatter plot shows the values increased each year. So one possible conjecture is that the average player in the NFL is earning more money today than in 1999. There's a conjecture, and it's probably true. Okay, I'll let you guys do these two. And that's it for today. I'll see you guys tomorrow.